The Trump White House is now in the middle of its third COVID-19 outbreak. News broke over the weekend that Chief of Staff Mark Meadows, Housing and Urban Development Secretary Ben Carson, and 6 other staffers tested positive for the novel coronavirus after attending a maskless election night party. In September, the Supreme Court nomination ceremony for Amy Coney Barrett, now labeled a superspreader event, brought down 35 people connected to the White House, including senators, staffers, and members of the press, not to mention President Trump and his immediate family. Additionally, there were reports of another outbreak within the orbit of Vice President Pence in October, with multiple staff members testing positive for COVID-19. The administration's publicized prevention strategy is to test every person who enters the White House every day using COVID-19 rapid tests. It's unclear, however, whether the procedures have been carried out as planned. Frequent screening using rapid tests is proposed as one way out of this pandemic, but if that strategy has failed more than once in the most privileged environment with the explicit goal of protecting the most powerful people in the country, is there any hope for the rest of us? It's up for debate whether the failing at the White House is due to a problem with the tests, the way they are implemented, or a shortcoming with the strategy itself. Daily rapid tests do provide a strong foundation of protection against an outbreak, experts say. However, testing shouldn't be the only tactic used, forsaking other defenses like distancing and masks. It's fairly obvious that what happened at the White House was the result of behaviors rather than a failure of testing. We would not advise people under the current knowledge of how COVID-19 is spread to gather in a crowded space without masks, says Paul Sachs, MD, Clinical Director of the Division of Infectious Diseases at Brigham and Women's Hospital. The principle is a good one, testing frequently as a way of immediately identifying potential infections, and then isolating those people, and using that to snuff out any outbreaks before they arise. Other experts are less convinced about the viability and protection offered by daily testing and say that outbreaks were inevitable, either because of shortcomings in human nature or with the tests themselves. There was too much hanging on the tests, and the tests are imperfect, says Melissa Miller, Ph.D., a professor of pathology and laboratory medicine at the University of North Carolina, Chapel Hill. One of the key takeaways from this entire episode is that we have to be really vigilant about making sure that whatever prevention strategies we deploy try to minimize fatigue to the extent possible, adds Dave O'Connor, Ph.D., a professor of pathology and laboratory medicine at the University of Wisconsin. It's really hard to have a testing program that's both frequent and that people don't get sick of. While the vast majority of Americans do not have access to regular, much less daily, coronavirus testing, the number of tests available in the U.S. has ramped up, and testing is slowly becoming a bigger part of the nation's strategy to combat the virus. Many Americans have now been tested, some multiple times, because they show symptoms, have had a potential exposure, or want insurance before or after traveling. As the U.S. hurdles toward its third wave of the pandemic, and with the winter holidays rapidly approaching, testing will become an even more important resource to keep you and your family safe. Here's everything you need to know about testing as a form of prevention, how accurate the rapid tests really are, and whether that Thursday test will let you see your family safely over the weekend. It's much better to do frequent testing with a lower sensitivity test than infrequent testing with a high sensitivity test. These are the tests available: the gold standard tests used to diagnose COVID-19 look for RNA from the novel coronavirus using a technique called RT-PCR, reverse transcription polymerase chain reaction. First, a nose or throat swab picks up cells in your respiratory tract. Next, RNA from the cells is extracted, isolated, and mixed with other ingredients that specifically bind to SARS-CoV-2 RNA, as opposed to the RNA from your own cells. Those bits of viral RNA are then translated into DNA and copied dozens of times, each replication called a cycle. If enough virus genome is present after a certain number of cycles, usually around 25 to 30, the test comes back as positive. This method is highly precise and can identify even minuscule amounts of viral RNA. But the tests take a long time and a lot of resources to process, and they have to be analyzed in a lab. A bottleneck in the processing of PCR tests this summer led to a backlog and 2-week delays to get test results, and waiting that long for an answer renders the test pretty much useless. What you should do if your COVID-19 test is delayed when test results take up to 2 weeks to come back. Is testing even worth it? Elemental.medium.com. Consequently, there was a big push for biotech companies to develop rapid tests that can spit out results within an hour and without the complicated lab equipment. Abbott won the race this spring with its ID Now test, followed by several other manufacturers. Subsequently, rapid tests have been rolled out to testing sites across the country. Tests like the ID Now are also PCR-based tests, meaning they still detect viral RNA, but because they can produce results in a fraction of the time, as fast as 15 minutes, they're less sensitive than a standard PCR test. To get a result in 15 minutes, you have to compromise something, Miller says. Either it's the number of cycling times that you're doing or the threshold at which you call a positive. There's some sort of compromise to get that rapid turnaround time. And so even though it is detecting the RNA, we know it's less sensitive. Even faster and cheaper than the rapid RNA tests are antigen tests, the newest technology authorized to screen for the novel coronavirus. These tests look for viral proteins, called antigens, which the immune system also uses to identify the virus as an invader. The rapid antigen tests appear to perform on par with the first round of rapid RNA tests, not as sensitive as the classic PCR tests but still able to detect the virus reliably when high levels of it are present. The White House was purportedly using an antigen test produced by Abbott, called the Binax Now, for its own screening, and the government recently purchased 150 million Binax Now testing kits to be distributed to schools, nursing homes, and businesses across the country. A major benefit of both types of rapid tests is that they don't have to be processed in a lab, further cutting down on the time and money it takes to obtain a result. Each test can be processed in a microwave-sized device that doctors' offices, pharmacies, and even some companies have purchased to use on-site. However, they are not as accurate as the classic PCR tests, raising concerns about faulty results. How reliable are the tests? Two words frequently thrown around when it comes to evaluating tests are their sensitivity and specificity. Sensitivity describes the likelihood the test correctly comes back positive if the person is infected. The metric is usually framed as how many true positives a person is infected and their test is positive, and false negatives a person is infected but their test is negative there are. PCR tests are the most sensitive, returning an average of 98% true positives, meaning that for every 100 people who are infected, the test will correctly identify 98 of them and miss 2 of them. The antigen and PCR rapid tests are thought to be between 85% and 95% sensitive, although there has been some concern about high rates of false negatives with some of the rapid tests. One study from May raised alarm bells about the Abbott ID Now test in particular when it showed that the rapid test had a sensitivity of only 60% compared to a PCR test. But Harvard epidemiologist Michael Mina, MD, PhD, says that finding was overblown. At issue was the sensitivity of the rapid test when very low levels of the virus were present. Remember, a consequence of the rapid tests being so fast is that they have to compromise in other areas, namely they require more of the virus to be present in order to return a positive test. Mina says that in the study, the cases the rapid test missed that the PCR test picked up had virus levels that were so low they wouldn't be contagious, and likely wouldn't be considered positive in a standard analysis. When the study was limited to a higher, more typically seen virus level, the rapid test jumped to a sensitivity of 93%. That was a failure of a paper, in my opinion, Mina says. Is the ID Now as good as the best PCR test? No. But it's a test that you can literally have out on a table in a park and use it anywhere. So there are some concessions, but it is one of the best rapid tests that's available. And it actually has a sensitivity that's up in the 90s, not 60%. More recently, and encouragingly, an independent assessment of the Binax Now rapid antigen test indicated that it was 94% as sensitive as the gold standard PCR test for people who are shedding live virus. Similar to the ID Now, the Binax Now did not pick up trace amounts of viral RNA that the PCR test was able to detect. But the cases the antigen test missed were not actually infectious, those people had already recovered from COVID-19 and the RNA found was from dead viral fragments. In fact, one criticism of PCR tests has been that they're too sensitive, and pick up RNA that is left over after the infection has already been cleared. A single person who has no symptoms and has been practicing social isolation and wearing a mask, already your pretest probability is very low. And then if you get a rapid test and that comes back negative, it makes it even lower. On the other side of the equation, specificity is how likely the test is to result in a false positive. A person is not infected with the virus but the test says they are. The best tests are about 98% specific, meaning that out of every 100 people who test positive, 2 of those people will not actually be infected with the virus. On an individual level, a false positive is less of a concern than a false negative because the person who receives the wrong result is not a risk to anyone else. However, it becomes a bigger deal if you start to screen whole populations of people, increasing your likelihood of getting back more false positives than true positives. With the current national testing strategy, the vast majority of positive cases are true positives, but if screening is ramped up to test every person every day, that could no longer be the case. For example, last month, nursing homes in Nevada were told by the state to stop using 2 different types of rapid antigen tests produced by the manufacturers Quidel and Becton, Dickinson, and Company because too many false positives, nearly 60%, were emerging. The state later rescinded the order after receiving pressure from the federal government. False positives are going to be a challenge for any frequent testing strategy in a low-prevalence population, says Sachs. That is an inevitable result of what's called low pretest probability. And when you have a low pretest probability, it greatly increases the chances that a positive test is a false positive. In order to offset the increase in false positives, Mina recommends the rapid test kits provide guidance and an additional swab to be sent in for a PCR test to confirm any suspicious positive results. Sachs, meanwhile, suggests that an algorithm could be used to weight a person's test results based on their potential exposure. What we have to put in place in order to counter that is a way of confirming these positive tests, he says. A good test is a test that people will get. One critical step that could make or break the surveillance testing strategy is how the sample is collected. Initially, tests were done with nasopharyngeal swabs, a long Q-tip stuck so far up the nose some people said it felt like it was tickling your brain. Fortunately, data has emerged that while there is a little less virus in the front of your nose than in the back, it's not enough to make a difference in the test result, so most samples can now be collected using a regular Q-tip just up to the bridge of your nose. The newest and easiest option for taking a sample is a saliva test, but it's up for debate whether these tests are as accurate as the swabs. One study from August showed that saliva samples actually collected more viral RNA than nasopharyngeal swabs. However, Miller says her team at UNC has found the opposite. In our personal experience of looking at saliva, there's less virus there than in the nasopharyngeal swab, and this is in symptomatic patients, she says. Still, a major benefit of spitting in a test tube over shoving a Q-tip up your nose is that most people would be willing to do the former a lot more often than the latter. When our campus health group switched from students getting nasal swabs to doing saliva collections, the numbers of kids that were showing up to be tested increased greatly, says Miller. If students are more willing to be tested by saliva, you have to consider that. Because if people aren't going to show up to be tested because they have to have a nasal swab, that defeats the purpose of testing. So sometimes you have to accept a lower sensitivity specimen and/or tests just because of either ease of use or ease of collection. A reluctance to submit to daily nasal swabs is one theory as to why the White House's testing strategy broke down. It's possible that people got tired of having their sinus cavities probed every day, so they stopped doing it. Even if you are able to get people to start getting tested, you have to keep them getting tested, says O'Connor. Even if you have all the support in the world, you might get sick of doing it after a while. Why testing strategy matters. The biggest question with the rapid tests is if they are not very sensitive with small quantities of virus, is it possible they'll miss someone who has low viral levels but is still infectious? Mina and O'Connor reassuringly say that if a person has enough virus in their nose to be contagious, they have enough virus to be detected by a rapid test. Put another way, if the rapid test isn't positive, in all likelihood, that person is not contagious at that time. It is possible, though, that the rapid tests could miss people who are at the beginning of their infection when they have low levels of the virus, are pre-symptomatic, and are not yet contagious. Those people will go on to become infectious in the coming days as the virus continues to replicate in their respiratory tract. This type of situation is why frequent or even daily rapid tests are recommended, because if that person took another rapid test in the next day or two, their infection would be caught, limiting the amount of time they could infect others. This gap in detection at the beginning of the infection is why the rapid tests need to be repeated daily or near daily to make sure they don't miss someone who is incubating the virus. We don't have to be so concerned about the sensitivity of the test if we're doing frequent testing, Mina says. It's much better to do frequent testing with a lower sensitivity test than infrequent testing with a high sensitivity test. As long as people are continuing to wear masks and social distance and things like that, frequency is what matters, much more than sensitivity. Another potential issue with tests as a form of prevention is the misconception that the tests alone are enough to prevent infections. Every expert interviewed for this article said the real issue with the White House's approach was that no other preventive measures, particularly masks and distancing, were taken beyond the use of frequent testing. You had a classic case of what we call risk disinhibition, O'Connor says. Because people were being tested, or because most people there thought everyone else was being tested, whatever the testing configuration was, that led people to take risks in that environment that they might not have taken in other environments, such as getting closer to people than they might have in their interactions, and not wearing masks. Echoing this concern, Miller says she worries that people who test negative will assume they have a license or a passport, so to speak, to do whatever they want, which is not the case. What this all means for you, right now. So how should you plan to use testing? Can you use it to confirm that you're negative before seeing friends or family? Or should tests only be used if you've had a potential exposure or are symptomatic? And, most importantly, can you be sure of the results, depending on which test you get? Sachs says that if you've been taking the recommended precautions, keeping your distance, only spending time outside with people you don't live with, and always wearing a mask when you're in crowds or an indoor setting, your risk of contracting the virus is very low. As a result, if you get tested and the result is negative, you can trust it. It's not testing or masks, it's all of the above. It's testing, it's masks, it's distancing, and it's being outside as much as possible. A single person who has no symptoms and has been practicing social isolation and wearing a mask, already your pretest probability is very low. And then if you get a rapid test and that comes back negative, it makes it even lower, he says. So for that individual to use the test as an additional safeguard before visiting their elderly family member is completely reasonable. It's important to note that a negative test only means you haven't been infected up until the point you had the test. If you wait several days between getting the test and visiting your parents, for example, it's possible you could be exposed in those intervening days. For this reason, a rapid test would likely be your best option in this type of scenario because you could get the results quickly for peace of mind. While many testing sites don't advertise the type of test they give, you can generally tell based on the turnaround time listed. If your results are returned within a day, you can be fairly sure that it's a rapid test, whereas a full-fledged PCR test will take a couple days to get results. Things are a little trickier if you haven't been super careful, perhaps going to indoor bars or restaurants, or if you or someone you live with has a job as an essential worker. In those situations, your potential risk of exposure, even without a known contact, is higher. As a result, a more sensitive screen using a PCR test would be preferable because there's a higher chance you could be incubating the virus, which the rapid tests wouldn't pick up. New Science suggests how to shorten quarantine testing upon exit of quarantine, ideally around day 6 or 7, is more effective than upon entry, and testing elemental.medium.com. If you have COVID-19 symptoms, you should immediately isolate and seek out a test. In this situation, either a rapid or a PCR test would be reliable, because if you're symptomatic, particularly during the first week, your viral load is going to be very high. If the test result is positive, you need to isolate for 10 days after your symptoms first appeared. Finally, if you have had contact with someone else who has tested positive, you should quarantine for the full 14 days because it can take that long for symptoms to develop after an exposure, or it's possible you could be asymptomatic and shedding virus but not know it. You can get tested during your quarantine, but keep in mind that a negative test on day 5 after exposure doesn't mean you won't develop symptoms and be contagious by day 9. In other words, a test will tell you if you're positive, which is valuable information in case you need treatment or need to isolate longer, but it won't guarantee you're negative. You really have to wait until 14 days to be sure. While the ins and outs of testing can be confusing, the most important message the experts want people to come away with is that prevention needs to be a multi-pronged approach. It's not testing or masks, it's all of the above, O'Connor says. It's testing, it's masks, it's distancing, and it's being outside as much as possible.